what we're talking about when we say it went left 2 and down 5, right? Okay, so that was easy. We have a parabola. Its vertex is -2, -5, because we moved it left. Here's where it started. We moved it left 2 and down 5. Okay, there it is. This thing is called the axis of the parabola, or I call it the axis of symmetry. You can call it either one, it doesn't matter. The axis of the parabola. And its equation would be x equals -2. The axis is a line, just like the asymptotes were lines, and so the equation, or the answer is going to be an equation. And it's going to be that vertical line intersects the x-axis at -2. Okay? So as long as your parabolas look like that, life is perfect. Unfortunately, they don't usually look like that. They usually look like number 27 on page 182. Now, is this a quadratic function? Yeah, it is. It has been all foiled out, though. Imagine if you foiled this out, wouldn't you get something that looks like that? So now our job, if our job is to find the vertex and axis of symmetry, that's what we're looking for, the vertex and axis of symmetry. We can no longer just look at the equation and give that information. If the equation looked like that, we could. So we're going to change this equation into this form. Now, warning, there will be fractions involved. It's just part of life, and we just have to deal with it. Now, in order to get from that to that, would you agree that I'm going to have to complete the square in order to get something that looks like that? So I'm going to get this equation ready to complete the square. You cannot jump in right now and complete the square. That number has to move over here. And this number has to go. It can't be there. As much as you want to keep it, you cannot. So everything has to be divided by 3. And here come the fractions. So we have 1/3 y plus 4/3 equal to x squared plus 5/3 x. Okay? Now what? I'm going to complete the square. Or what in the world is that? A neuron?
Yeah.
And that's all candy?
Can I have a piece? Oh, there's some glue on it.
Oh, okay. We don't get to do fun stuff like that in math. We'll figure out a project. Only if the teacher gets all the chocolate. All right, so here we go. We're going to complete the square. So how does that work? It's now ready. We're going to complete the square. We're going to add something to both sides. Who remembers how we find what we add to both sides? I'm going to add something to both sides of this equation, Maya. Exactly. And since that's a fraction, instead of instead of dividing by 2, I'm going to just multiply by 1/2. That's the same thing. And it's easier for me in fractions. So take 1/2 of this number, divide it by 2, take half of it. That gives me what? 5/6. And then, like Maya said, square it. So the number I'm going to add to both sides is 25/36. Now, if you did what you're supposed to do, this now is your perfect square. That should be x plus what squared? What's going to go here? Not 5/3. 5/6. That's going to be x plus 5/6 squared. And then over here, we're going to have to add these two things together. Okay? So how do we add 4/3 and 25/36? We get a common denominator, which would be, we gotta multiply this one by 12 to get 36. So that's 48 and 25, and 48 and 25 makes, what, 73? Now we're getting closer. Remember, this was our goal. Okay? So what do we need to do to get to our goal? Subtract 73/36. So we have 1/3 y equals your parentheses minus 73/36. Okay. And then one more thing to do to make it look like this. Times by 3. Now, when you times by 3, you're going to multiply the parentheses by 3, but nothing in it. Don't multiply what's in the parentheses. Multiply the whole parentheses by 3, and don't forget to multiply that number by 3. So y equals 3 times x plus 5, 6 squared. Okay, now when you multiply, we can cancel there a little bit, can't we? So 73/12. Fractions are just a part of this process. Unless, you know, the problem is very carefully rigged, you're just going to end up with fractions. So, the goal was to find the vertex. Can we now look at our equation and find the vertex? This parabola has been moved how? Left 5, 6, and down 73/12. So negative 5, 6, negative 73/12. So here's my parabola. Negative 5, 6, negative 73/12. Here's my axis of symmetry. What is the equation of my axis of symmetry? X equals negative 5, 6. Okay, let's try another one. Oh, we'll just make one up. Let's say 1/4 x squared minus 2x plus 5. Alright, and our job is to find the vertex and axis of symmetry. This is a quadratic function, quadratic, degree 2, using our vocabulary from the other day, degree 2, quadratic. Here we go. Step 1. We're going to subtract the 5 and times by 4. And we're going to times everything by 4. Oh, this one's going to work out better. Now what?
Complete the square.
Now we're going to complete the square. And how do we complete the square? We take half of 8, which is 4, squared is 16. So that's an easy one. This is going to work out great. So this side should be a square. What is that? X minus 4 squared. Very good. And over here, no common denominators necessary. It's 4y minus 4. Now we just have to get y by itself. So we'll add the 4 back over. what's our last step? Divide by 4. Now, again, it's the parentheses being divided by 4, not anything in it. Do not touch what's in the parentheses, but you're dividing, oops, I did not there. You're dividing the parentheses by 4. So I have 1/4 of the parentheses. So where's my vertex? That was our goal. Vertex is at 4, 1. Very good. We went right 4, up 1, and our axis of symmetry is x equals 4. Perfect. Now there's a section in the homework for 2.1 that says find the vertex and axis by completing the square, and that's what you do. Okay? Now, there is another way to find the vertex and axis of symmetry of a parabola, and I think you probably already know it. So let me make up another example. Okay? I'm going to show you another way to find the vertex and axis of symmetry. Now, this is called the vertex form of the parabola. Because if the parabola is in this form, you can look at it and tell me the vertex, right? If you don't want to take the time or don't have to take the time to put it in vertex form, you can find the axis of symmetry using a little formula, x equals negative b over 2a. You remember that from last year? Now, remember, this thing, negative b over 2a, gives you the axis of symmetry. That's what this is a formula for. The a, b, and c are just like you would use in the quadratic formula. So a is 2, b is 5, c is negative 7. So negative b over 2a tells me that my axis of symmetry is negative 5/4. But your objective is not just to find the axis of symmetry, you also want the vertex. Any idea how we can use what we already know to find our vertex?
You know what the x coordinate is?
I know what the x coordinate is. Kids, I certainly hope you've noticed that no matter how you draw your parabola, no matter where it is, isn't the x coordinate going to be the axis of symmetry? So if you know your axis of symmetry is negative 5/4, then that means your x coordinate's negative 5/4. And how will we find our y coordinate? Plug it in. So here are the fractions again. They're just part of it. So we plug it in, and we'll have 2 times negative 5/4 squared plus 5 times negative 5/4 minus 7. All right, so here I am. So that's 2 times 25/16 minus 25/4 minus 7. Keep an eye on my arithmetic. Don't let me mess up. So I can cancel here, so that's 25/8 minus 25/4 minus 7. How am I going to collect all that, combine all that? What am I going to have to do? Get my good old common denominator again, which would be 8. So I have 25 minus 50 minus 56. Which is, let's see, what would that be? Negative 81. So negative 81/8. You are free, unless the directions tell you otherwise, and in the book they do, so pay attention. But unless the directions tell you otherwise, you are free to find your vertex whatever way you want. Okay? All right, now we're going to look at problem number. We're still on page, well now we're on page 183. But now we're going to look at a problem like number 39, which is backwards of what we've been doing. All right? Try to get excited. This is good stuff. We've got a parabola, and its vertex is -1, -3, and it contains the point 1, 5. So this is problem 39 on page 183. If you have started your 1-5 homework, you know, or excuse me, your 2-1 homework, you know that this kind of thing is in there. Your job is to write the equation of the parabola. You've been given a vertex and some other random point on the parabola, and you are going to write the equation of it. Now, what thought do you have? Other than, I wish I were still home in bed. What do you think? Well, I know the axis of symmetry, it would be x equals -1. Sure thing. I want you to think about your vertex form of your parabola. Here's an example. Okay, this is the vertex form of the parabola. From this form, I can tell you what my vertex is, right? My vertex would be 3, 5. Now, can you use that idea to construct at least part of this equation? Y equals, what's in this parentheses? X plus 1, and then -3. Would everybody agree that that parabola that you just wrote has a vertex left 1, down 3? Which that one does, right? Now, are there other parabolas besides the one I drew that have a vertex at -1, -3? Yes, you could pretend my head is -1, -3. Well, no. Anyway, I'm a parabola, okay, with a vertex of -1, -3. I could look like this, 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 right? There are tons of them that have that vertex. What controls the specific one that goes through that point? This number out here in front, right? Because what does that multiplier do? Control how fat I am? Or what direction I'm in? So I need to figure out what that number is, because I don't want just any parabola that goes through that point. I want the one that's just wide enough to get him. So any ideas how we might figure out what that missing number is? Patty?
Plug in variables?
What do you want me to plug in? You're right. What am I plugging in?
Not the vertex, but the control point.
Exactly. This is an X and a Y.
We plug in 1 for X and 5 for Y.
Exactly.
Then basic arithmetic.
You got it. So I use my vertex to start at the base of the equation done. And then, as Patty said, I put in the point that controls the width to figure out what that number is. So 5 equals, 1 plus 1, that would be 4n minus 3. So that number is 2.
Yeah.
So your answer is right there. All right, let's try one more. Let's say we have a parabola whose vertex is 1, 2, and it contains the point 4, -7. So, step 1, build the foundation. What is the foundation of your equation? Y equals.
Did you make this one?
I did. x minus 1, thank you, Anna, x minus 1 squared, don't forget the squared, plus 2. Everybody okay with that part of the equation? That's the vertex. Right 1 up 2. Now we need to find that control number, or whatever you want to call it, that makes sure we go through that point. So what did we say we were going to do, Emily? To find that number? Yep, so I'm going to put -7 here, and 4 here. Make sure you're putting that in the right spot. This is x and y. So 4 minus 1 is 3 squared, so 9n. Oh my gosh, I can't believe I'm going to go buy a lottery ticket. Look how cool this came out. -9 equals 9n, so n equals -1. So my equation is, hey, does it make sense that number's negative? Why? Because it opens down. Everybody good? Okay. Now we're going to turn the page, because now we got some excitement. We have some word problems. And you know how in the last section there were a couple kinds of problems, like the box problem and the mixture problems that we just kind of focused on? Well, there are a couple in here we're going to focus on. Okay? So one that I would like to focus on would be number 56. So if you take a look on page 184 at number 56, all right, so here we go. We have a large painting. It's 3 feet longer than it is wide. Okay, so how am I going to express that? It's 3 feet longer than it is wide. So I'll let the width be x, and then the length will be 3 plus x, or x plus 3. Is that okay with everybody? All right. If the wooden, so the wooden frame is 12 inches wide, so the wooden frame is 1 foot wide. The area of the picture end frame is 208. Okay, so we have, I'm going to move these. So we have a frame going around the picture that's 1 foot wide. And we know that the area of the whole thing, that's frame and picture, the area of the whole thing is 208. Well, it's a rectangle, right? How do we find the area of a rectangle? Length times width. So I need this times this. That whole thing, right? So tell me about this. What would this be? X plus 2. Very good. Why is that x plus 2? Patty?
Because the additions of, I can't think straight. Because of the 1 foot width.
On each side. So you have your original x, but then you've added a foot on both sides, so that's x plus 2. What about this one? X plus 5.
Is this more?
Yeah.
How do we know that it's 1 foot on each side?
It says the frame is 12 inches, so I made that a foot,
Okay.
right? Since the other thing was in feet, that was in feet, so I went ahead and changed it to feet. So 208, which is the area of the whole thing, equals x plus 2 times x plus 5.
Oh.
Length times width. All right, what do we do here? Gotta FOIL it out. So we have x squared plus 7x plus 10 minus 208, so we have x squared plus 7x minus 198.
Oh boy.
Now, if you're good at factoring and you remember all the times tables you memorized when you were in elementary school, then you probably can go ahead and factor this. If you can't factor it or don't want to mess around with it, then you could always do what? Quadratic formula. It does factor. 198 is 18 times 11, I think. So we have x plus 18, x minus 11. But again, if you don't want to mess with that and you're sitting there with the calculator, go ahead and do the quadratic formula and you'll come up with the same two answers, negative 18 and 11. What are you going to do with that one? Throw it out. That's an extraneous root. In the context of the problem, x cannot be a negative 18, right? But it could be 11. So what did we want to know? The dimensions of the painting. So the dimensions of the painting are 11 by 14. Remember, this was the painting. 11 by 14.
Wouldn't it be 13?
What?
Wouldn't it be 13 because you plug 11 to the x plus 2?
No, it said the painting. This is the painting, this includes the frame. It doesn't say the dimensions of the whole thing. It says the dimensions of the painting. All right. Now, another problem you have to be able to do would be one like 59. The beverage business. Okay, so let's talk about this. This looks like an econ problem. The Sweet Drip Beverage Company sells cans of soda pop. It finds that sales average 26,000 cans per month at 50 cents. So that's what we're starting with. They sell 26,000 cans at a price of 50 cents. That's how it starts. For each nickel increase in price, so every time we raise the price a nickel, sales drop by 1,000. So we lose 1,000 cans every time we raise the price a nickel. Now, if you are in business, if you're the Sweet Drip Beverage Company, you want to make the most money you can, right? You want to maximize your profits or your income. In this case, our income. We want to maximize our income. Now, that means finding that balance between the right price to charge and the right number of cans to sell to give you the highest total, right? How much do we make right now? How would you, if we don't make any changes, we're selling 26,000 cans at 50 cents a can, how do we find our income? How much would we be making? $13,000. Because when we find income for when we're selling things, it's the number we sell times the price each, right? Doesn't that make sense to you? And right now, you are selling 26,000. But what's going to happen to that number?
It's going to drop.
It's going to drop. So it's going to be minus. Now, minus what?
1,000x.
1,000x. Now, Sam, 1,000x. Why is it 1,000x? What are you letting x stand for? Not the cans.
Lost.
The increments of price.
The number of times we change the price. That's exactly right, Patty. The number of price increases. Because every time I raise my price, what happens? I lose 1,000 cans, right? So if I raise it once, I'll lose 1,000. If I raise it twice, I'll lose 2,000. 3 would be 3,000, and so on. So what I'm trying to figure out is, how many times should I raise my price? X is the number of times I'm going to do it. So I started out selling 26,000. I'm going to spread this out so I won't. I started out selling 26,000, but I'm going to lose 1,000 for every X. Now, I started out selling them at 50 cents, but what's happening to that now? That's adding. And what is it at? What am I adding to that? 0.05x. Because every X will add 5 cents to the price. Does that make sense to you? So we started out, these are our base numbers. Price is going up, sales are going down. Sales are going down in increments, I love that word, of 1,000. And the price is going up in increments of 5 cents. And we just want to know how many increments. How many times we're going to change it. All right? So here's what I want you to do. I want you to multiply that out. I want you to FOIL it out. So that'll be 13,000. You can do it. Use your calculator if you need to. I got negative 50x squared plus 800x plus 13,000. They double check that for me. I could have easily made a mistake. What do you think? Is that okay?
That's what I got.
All right. Okay. All right. What kind of a function is this? It's parabola. It's quadratic. The question, oh, by the way, see that negative right there? What does that tell me about my parabola? It opens down. So I've got a picture that looks like this. And the question said something about maximizing the income, right? Now wait, maximizing the income. I know your calculator will do that, but you don't need a calculator. Because what about the maximum of that parabola? It's the vertex. So what I really want to know is, what is my vertex? X equals negative b over 2a. I got 8. X equals 8. Now, wait a second. What is that 8? 8 what? Is that 8 cans? $8? 8 what? 8 increases. So the question said, how much should Sweet Drop charge per can? Now wait a minute, how much did we originally charge per can? 50 cents. This says I should raise my price 8 times. Well, each time is worth 5 cents. So I'm going to increase it 8 times 5 cents, 40 cents on top of the original price of 50 cents. So the answer to the question is 90 cents. So I should charge 90 cents per can. Now the second part says, what is the maximum revenue? I've been using income, revenue, same thing. What is the maximum revenue? Now, when you found the vertex of your parabola, you found the x-coordinate was 8. That's what we found x to be 8. Y represents the revenue, right? So you got a couple of options. You can either plug 8 into your equation, wouldn't that give you y? Or you can come back and figure out, okay, you already figured out that 90 cents is your optimum price. So you could figure out, okay, if I raise my price 8 times, I'm going to lose 8,000 cans. So I would be still selling, what, 18,000 cans?
Yeah.
At 90 cents each? And you could calculate your revenue that way. So you gotta have y. So you're either gonna plug it in down here, plug in 8, or you're gonna go ahead and figure out how many cans you're selling and multiply that by your 90. And that will be your maximum revenue. Okay? Let's get another one at least set up. That was what, 59? Let's do 58. Okay, let's get this at least set up for you, because I'm sure I assigned this problem, so let's make sure you can at least set it up. All right, so it's another one.
Mrs. Moore?
Yeah.
We aren't doing 58.
Well, we're gonna do 58 anyway. We need to practice. It's gonna be a test question, Maria. Thank you, but it's gonna be a test question. Okay, so here we go. We have 16,000 units available. Okay, forget that for a minute. 800 are currently rented at $300 a month. So this is the number of units, and this is the rent. So if you are this apartment complex manager, how much income are you bringing in right now? 800 times 300, right? But what's going to happen? For every $5 decrease in rent, so now we're going down by increments of 5. For every $5 decrease in rent, what will happen? I will have 20 more apartments rented. So right now, I'm $800 and $300. What's happening to the number of units I'm renting? Going up by 20s? And what's happening to my price? Going down by 5s? Where X is the number of price changes, price decreases this time. So this is your equation. Now, will that be a parabola when you get it all multiplied out? Yes. Will it be a parabola opening down when you get it all multiplied out? So the question talks about maximum. So you will again find the vertex. Now, when I found this vertex, I used the formula. If you want to complete the square and all that, you can. But yes, you need the vertex. All right? Okie dokie, Smokies. Good work. Your tests are graded and in college school if you didn't already know that. See you tomorrow.